Okay? Let's do one more. Give me formation reaction. For lithium bromine. Okay? Lithium bromine. So that's LiBrO3. Formation and synthesis, same thing. So now we have 3 elements instead of 2, so 3 elements got to react together. We're going to pound into each other, we're going to collide. All mayhem. Li plus Br plus O yields LiBrO3. Alright? Now, first thing, check for diatomics. Is lithium a diatomic molecule? Check the list, not on the list, so we don't put any there. Is bromine a diatomic molecule? Yes, it is. Put a 2 right there. Is oxygen diatomic? Well, we've had that one already with water, so sure, that's diatomic. And because that's a compound, we don't worry about diatomics with that one. Second thing. Oh, now it should have been the second thing. First thing should have been phases. Duh. What's the phase of lithium? Well, you look at the exceptions. Is it a liquid? No. Is it a gas? No. That makes it solid. Bromine. Is it a liquid? Yeah, it's one of the 2 liquids at room temperature. So there is an L. And oxygen we already know is a gas. Dangerous or we'd be dead. Lithium bromide. Or bromate, lithium bromate. Is that a solid, liquid, or gas? Well, the question really is not that. The question is that an ionic compound or a covalent compound? And since it has lithium, which is a metal, that makes this ionic. The fact that lithium is a metal means that this is going to be a solid. We'll put an S right there. Okay, should have done that first. I got so excited with the fact that I didn't have a diatomic molecule. My goodness. Now we got to balance it. Li1, Br2, O2, Li1, Br1, O3. Well, the lithiums are balanced. So we don't have to worry about lithiums, at least for the moment. Bromines, however, are not balanced. You got 2 here, you got 1 here, but we got to have a 2 here. But we don't put the 2 in the middle of the compound. It has to go in front of the entire compound that has the bromine in it. We'll put a 2 right there. That now changes the amount of lithium to 2. Bromine is now 2. And oxygen now is 6. So that doubles everything in that compound. So we go back over here. Oh, shoot. Lithium's no longer balanced. So we got to do something about it. Well, we got to have 2 lithiums instead of 2. Bromine is balanced. That's nice. That's what started this whole mess. And oxygen's got 6 over there and 2 over here. So 3 there, because 3 times 2 is 6. And that is now your balanced formation reaction for lithium bromine. That's how it works. Okay? The next thing we're going to talk about is the decomposition reaction. Now, a decomposition, if something decomposes, what happens to it? Well, it literally means breaking apart. And so, as I stated at the very beginning of this thing, this is exactly opposite of synthesis or formation. Instead of taking atoms and creating compounds, you're going to start with a compound and break it down into its atoms. Okay? So this is the opposite of synthesis or formation. Are you familiar with the composer Wolfgang Amadeus Mozart? You know what he's doing right now? He's decomposing. And so we want to write the decomposition reaction for let's use magnesium. And we'll use, let's use FO3, 2. That's the compound. This is magnesium fluoride. All right, now, like I said, decomposition is the same as the opposite direction of synthesis or formation. So I'll write this in green because this isn't what it's going to be. But if we treated this like a formation reaction, this would be Mg plus F plus O yields Mg FO3, 2. That's what it would look like because this is a formation reaction. But it's not. This is not what's going on. But it's close. And you got to be careful with this when you do the practice problems because it's very easy to get this to turn around. This should be what you start with, and this should be what you end up with. So the actual equation for this is going to be the compound MgFO3, 2 yields Mg plus F plus O. Okay? Now, step 1 on phases. Start with this. What phase is this going to be? Well, it's a compound. So we have to figure out if it's ionic or covalent. What makes something ionic? Well, it has to have a metal. Do we have a metal here? Sure do. Magnesium in group 2A, that's a metal. Therefore, this is a solid. Magnesium. Is that a liquid? Is that one of the liquids? No, the liquids are mercury and bromine. Is that one of the gases? No, gases are hydrogen, nitrogen, oxygen, fluorine, chlorine. That leaves solid. In fact, you know magnesium because that's what makes the sparklers do what it does on the 4th of July. Or any day for that matter. Fluorine, solid, liquid, or gas? Well, that's in the list of gases. Hint, if you're near some fluorine gas, run away. This stuff is dangerously bad for you. It's pale yellow gas, and all it does terrible things to your internal organs if you accidentally breathe it in. Oxygen, of course, we know is a gas. Now, we got the phases done. We balance the equation. No, before we balance the equation, we come up with the diatomics. We don't worry about this because that's a compound. Is magnesium one of the diatomics, one of the 7 diatomics? Nay, I say nay, nay, nay. Fluorine is, however, and of course oxygen is, because we've only seen it like a bajillion times already. Now we balance this thing. Mg1F. How many fluorines do we have here? Well, that parenthesis in the 2 on the outside tells us we have to double everything on the inside. So we got 2 here. And how many oxygens do we have? Well, 3 times 2 is 6. Be careful. 3 times 2 does not equal 5, and I can't tell you the number of students who have done that. Multiply, don't add. Words to live by. Mg here is 1, F is 2, O is 2. Well, this looks pretty easy. Magnesium's already balanced. The fluorine is already balanced. The only not balanced is the oxygens. I need 6 over there. That's easily fixed. I put a 3 in front of that because 3 times 2 is 6. And ta-da! Balanced. Decomposition reaction. Easy, right? It is. So, your assignment, your practice problems are these 5 right here.